So hello everyone, so now we are going to look into area of a region bounded by the curve and the y-axis. Before this we have seen area of a region bounded by the curve and the x-axis. So now if f and g are continuous with fy greater than or equals to gy throughout AB, then the area of a region between two functions x1 equals fy and x2 equals gy from y equals a to y equals b is the integral of, okay, so this will be the formula. So just like the previous videos which we have learned, however we'll change it into terms of y. So the function must be in terms of y. So before this, when we find the area of a region bounded by the curve and the x-axis, the terms inside, so the terms of the function is in x. So now when we want to find the area of a region bounded by the curve and the y-axis, the term inside the function has to be y. Okay, the function has to be in terms of y. Why is it in terms of y? Because we are going to integrate it with respect to y. So we put here dy. So this is how you find the area of a region bounded by the curve and the y-axis. So whenever you want to find, whenever you see y-axis here, so the functions inside has to be in terms of y, and you would need to integrate them with respect to y. Okay, so as usual, we can also rewrite this formula. Okay, as x1 equals fy and x2 equals gy, so this is our fy and this is our gy. We can also rewrite this formula into x1 minus x2, so dy. Okay, this is another form of the formula. Okay, and the last one, the last form of the formula, before this, to find the area of a region bounded by the curve and the x-axis, we take the upper function minus the lower function. Okay, and we integrate them with respect to x. So that was the previous case. However, in this case, when finding the area of region bounded by the curve and the y-axis, what we need to do is, it is easier for us to use this formula, which is you take the integral from a to b, and you take the right function. So the right function minus the left function, and the whole thing you need to integrate with respect to y. So you put dy. Okay, so before this we have taken the upper function minus the lower function. So that is for area of region bounded by the curve and the x-axis. So for area of region bounded by the curve and the y-axis, you take the right function minus the left function, integrate them in the interval with respect to y. Okay, so the function has to be in terms of y. So how does it look like graphically? Okay, so we are going to sketch. So let's say we have a function. Okay, we have a curve and it's bounded by the y-axis. So let's say this is A and this is B. So this is your x-axis, this is your y-axis. So now this is an example of a curve, the curve and also the y-axis. So the area of the region bounded by the curve and also the y-axis will be this area here. Okay, so how do we go about finding this area? So this is our main aim, to find the area bounded by the curve and the y-axis. So like what we said in the previous slide, we'll take interval from a to b, interval from a to b, and we take the right hand function. So this will be your fy. Okay, so you take fy because fy is the right function. So this is the function on the right minus the function on the left. So the function of the left will be x equals 0. So this will be 0. Integrate them with respect to y. Okay, so you'll get a, b, f, y, dy. Okay, so that is how you find the area. Now let's say you have another graph like this. This is your x-axis and this is your y-axis. So you have a graph on the left hand side of the y-axis, and you are required to find the area of the region bounded by the curve and also the y-axis. So this is your interval A and this is your interval B. So the curve, so I'll just label the curve as fy. Okay, so where is the region that we want to find? So this is the curve and this is y-axis. So the area of the region bounded by the curve and the y-axis will be the area that I'm shading right now. So this area is the area that we want to find. So how do we go about finding it? We call our formula A to B. We take the right function minus the left function. The whole thing you would need to integrate with respect to y. Okay, because we are currently finding the area of a region bounded by the curve and the y-axis. So that's why we integrate with respect to y. So these functions inside has to be in terms of y. Okay, so what is our right hand function? So right function is at x equals 0. So this will be 0. So minus our left function. Left function is fy. So fy is on the left. This is at x equals 0. Okay, so this will be dy. And then we'll get this formula, ab minus fy dy. We can bring the negative out. bfy dy. So you'll obtain this formula. Okay, so next we're going to look into more examples. So in this example, we are going to find the area bounded by y equals zx, the y-axis, the lines y equals 0 and y equals 3. So how do we go about finding it? So first I'm going to sketch the curve so that we get a better view. So this is how y equals zx looks like. Okay, and this is 0. This is y equals to 3. So now we are required to find the area bounded by the curve and also the y-axis. So the curve and the y-axis. So we have the curve here, the y-axis. So where is the area? So the area is the one in between them. So this area is the one that we are going to find. However, when you were to find the area of a region bounded by the curve and the y-axis, your function has to be in terms of y. And so right now, what we have here is y equals zx. We have a function of y which is in terms of x. So you should have noticed that y is actually equals to x to the power of 1 over 2. So when we want to write this in terms of y, we can make y squared is equals to x. So now we have x is equals to y squared. So we have already changed it in terms of y. Okay, so remember that to find the area of a region bounded by the curve and the y-axis, the function has to be in terms of y. So to find the area of the region that I've shaded, okay, the region bounded by the curve and the y-axis, we would need to take the integral from 0 to 3. Okay, because y equals 0 and y equals 3, so we'll take from 0 to 3 is our interval. Okay, then we'll take the right function minus the left function. So the right function is x equals y squared. X equals y squared. So remember that when we find the area bounded by the curve and the y-axis, we would need to write the functions in terms of y. So there we have already found the function in terms of y. So we'll take y squared. So because this is x equals y squared, and this is x is equals to 0. Okay, so at this point x is equals to 0, so we'll put minus 0. The whole thing will integrate with respect to y, so we put dy. Okay, so we can rewrite, and it becomes y squared dy. So then we start to integrate. We'll get y to the power of 3 over 3, 0, 3. So this is easy for you to calculate. You'll get 3 to the power of 3 over 3 minus 0. Okay, because when you substitute in 0, you'll get 0. So this is equals to 27 over 3, which is also equals to 9. So 9, remember it's unit squared because we're finding the area. So there you go. So that is your final answer.